Hello beautiful people, my name is Peter. Welcome to this tutorial. In this section we are going to be discussing organic chemistry 1, and today's topic is the R and S naming systems. So these were discovered by the three scientists, Kahn, Indog and Prelog. So we call it the Kahn, Indog, Prelog system. So today's objectives will be, we shall look at what we call the meaning of the word chiral, asymmetric center, stereo center, and then the perspective formula. So this is just an intro into this is naming the R and S system. So I will throw these words at you as time goes on by, so it's better for us to get to know what they mean as before we go on into the topic. So the word chiral, chiral or a chiral center means a non-superimposable image. So a good example of this is when you try to put on your right hand and a left hand glove. So these two images are non-superimposable. So a chiral center is like a mirror image of another. For example, when you put up your right hand in the mirror, it will reflect your left hand. So now these two images are what we call non-superimposable. They cannot be put together. They cannot come together in a uniformity. So another definition that we shall see is the asymmetric center. So an asymmetric center is usually a carbon. So this carbon usually is bonded to 4 different atoms. It's bonded to 4 different atoms. And usually asymmetric centers and chiral centers, we always interchange these words, but they literally means the same. You can use a chiral carbon, meaning a carbon which is bonded to 4 different groups. So I have here an example of this model. So if orange represents bromine and green represents chlorine, then black usually is for carbon, and white is for hydrogen. So now, what we mean by a chiral center or an asymmetric center or an asymmetric carbon is this carbon. It is bonded to a bromine, a chlorine, a hydrogen, and a methyl group. So if I may draw this structure to show you how this carbon looks. So if this is my carbon, it's bonded to a methyl group. It's also bonded to a chlorine group, a hydrogen, then a bromine. So let me do this. Bromine, and then hydrogen in this form. So when I draw like this with this wedge and the dashed wedge, they mean that when this bromine is facing you, like the way you see it like this, so this is how it is. So when the bromine is facing you, whereas the hydrogen is in the back, the methyl group is up, and the chlorine atom is just on the side. So this is how I've drawn this structure. So usually this is how an asymmetric carbon or an asymmetric center looks like. So if we go to what we call a stereo center, so an asymmetric center is also a stereo center. Remember when we talked about stereoisomers, we said they only define their arrangement in space. So now this carbon is a stereo center because I can rearrange this molecule to get a different spatial arrangement. So a stereo center can be an asymmetric center, and also we saw that in cis and trans, those also produce what we call stereo centers. So this carbon is a stereo center, and also if I have hydrogen, hydrogen. So if I have this alkene, so this is a stereocenter and this is a stereocenter. And also, this carbon is a stereocenter. So all these carbons are stereocenters, meaning that if I change them, if I change anything around this carbon, it will produce a new spatial compound, or it's a compound. So now, when I look at this alkene, so we can say that all stereocenters, all asymmetric centers are stereocenters. So this is an asymmetrical center, an asymmetrical carbon. It has a stereocenter, and not all stereocenters are asymmetrical. So this compound is bonded to a hydrogen, a methyl group, and 2 double bonds. So this carbon is not chiral, and it's not an asymmetric center, but it is a stereocenter, because we can obtain cis and trans when we move forth these atoms from their positions. If this hydrogen comes down and the methyl group goes up, then we get a cis isomer. This is a trans isomer. So it is a stereocenter. The same applies to this carbon. But these 2 carbons are not chiral. They are not chiral, meaning that they are not bonded to 4 different atoms because of these 2 double bonds. So therefore, an asymmetric center can be a stereocenter, but not all stereocenters can be asymmetric centers. So I think that's clear about the stereocenter and asymmetric center. So now, let me drop down to what we call the perspective formula. So again, if I may use this compound, so this is what we call a perspective formula. So this is how we represent it in form of perspective. We know that carbon bonds are in a tetrahedral form when it forms an it has an sp3 hybridization. It forms what we call tetrahedral molecules. So how do we represent tetrahedral molecules? So this is how we represent the molecules. So if this might be choline and this my hydrogen. So this is what I had drawn previously. So in this form, it means the bromine is facing me, the hydrogen is very far away from you, the chlorine is on the other side, and the methyl group is on top. So now, to begin with this molecule, how do we name a molecule like this using the R and S system? So now, if I may take off this. So, before naming a molecule in R and S system, the first thing you have to know is you have to list them in the order of priority. So remember, in the E and Z system of naming alkenes and alkenes that do not have a hydrogen in their sp2 carbon, so we use the order of priority. So in form of atomic numbers. So the higher the atomic number, the higher we give the molecule first priority. So after naming that, then we shall, if we have a clockwise, so after naming after giving them orders, then you make sure that the lowest priority is in the hatched wedge. So this is the hatched wedge. So after giving them the order of priority, the lowest priority must be in the hatched wedge. So and usually it's hydrogen. Sometimes it's not hydrogen, but most of the cases it's hydrogen. So then after that, if you have a clockwise counting or a anti-clockwise, so if you have a clockwise counting when the lowest priority is in the fourth position, then you have an R isomer. So if it's in it's an anti-clockwise, then you have an S isomer. So let us use this as our example to illustrate what these are priorities that I've put forth on the board. So now, to begin with this, the order of priority. So if bromine is my number 1, because it has the highest priority, then followed by chlorine, number 2, then carbon is number 3, and then lastly, the hydrogen is number 4. So now, this is my priority. So now, the lowest priority must be on the hatched wedge. So the hydrogen is already on the hatched wedge. So therefore, we are done with that and done with this. So now we are going to count. So if our counting is on the clockwise, it is R. If it is anti-clockwise, it is S. So for this case, this is an R isomer. So this is how we identify. So if I may use another example, because this was a bit straightforward. So if I can move the chlorine and I put it here, and I move the hydrogen and I put it here, and see how the system will be. So now, so this is my compound. So now, how am I going to name it? So if I may use this is the bromine. The bromine is facing you. Okay, I've already rearranged the molecule. So what we have to do is, first of all, order of priority. So this will be our 1, our 2, and our 3. So if this is the order of priority, but this hydrogen is not in the hydrogen is not in the fourth position, we have to move this hydrogen to this position. So how do we do that? We have to rotate. So if this is the molecule, okay, if I may say, the green is bromine, the white is hydrogen, and the chlorine is the one which is very far away. So if I want to make this hydrogen go to the behind, I have to rotate this structure like that. So now you can't see the hydrogen because it's already in the back. So what I've done is I've rotated this molecule in this direction. So remember, this methyl group didn't move because it's on top. So our final compound will be CH3. Then the hydrogen will go back. So now the bromine, the chlorine will come in this position where the bromine was, and then the bromine will go in the position where the hydrogen was. So now this is our final structure. So then we have to do the order of priority. So this will be carbon number 1, number 2, and then number 3. So as long as the hydrogen is in the hatched wedge, you assume that you don't see it. So you just count 1, 2, 3. So this is anti-clockwise, giving us an S isomer. So basically, that's how we name molecules S and R. So if we may use another example from a different molecule. So I have here another different molecule. So this one is a carbon and a methyl group, hydrogen. This is OH, and then if green is chlorine. So now this is the molecule I have. This is how it is. So now, if I want to name this either R or S, remember, order of priority. So if this is my chlorine, is going to be my number 1. So this is number 2, and this is number 3. Now, since hydrogen is already in the hatched wedge, we assume that we don't see it, so we don't count it. So we shall just count as it goes. So which is an S isomer. So this is an S isomer. So this compound, if this compound is a CH3 C to the OH, then to the Cr. So this is ethanol. So it is a 1 chloro ethanol. So this is 1 chloroethanol, but it's an S isomer. So we say S 1 chloroethanol. So this is how we name. So now this is an S isomer. I have an R isomer of the same molecule, which looks like this. So the R isomer has a carbon methyl group. The OH is here, the chlorine is here, and then the hydrogen is here. So now, naming in order priority, this will be my number 1, number 2, number 3. So this is giving me an R, a clockwise direction, which is R. So now, there is what we call enantiomers. So if we have a chiral center or an asymmetric center, there always exists what we call enantiomers. So therefore, R and S are called enantiomers. The one enantiomer means opposite. So R and S are opposite of each other. So if I have these two compounds, one is L and one is R and the other is S. So now if I may show you how these compounds are mirror images of each other. So this is how it is. Remember, one of these gave us an S and the other gave us an R. So these two images are, this is how they look like when they are mirror images. So when remember, if this is the real image, so when you take a look in the mirror, this will be the image which is reflected. So this is how you draw these two compounds. If they ask you to draw, if they give you an R isomer and they tell you to draw the S isomer, you just draw the mirror image of it. How? So by making sure that these two look the same, they are on the same side, and the hydrogens are very far away from them. So basically that's all about the R and S system. In my next video we shall do a number of examples so that we nail this system further, and so that you understand it, because you're going to encounter it more and more times as we go further in organic chemistry. Thank you very much. Bye for now.